The village of Valthermond lies in northeastern Netherlands in the province of Drenthe. The village is named after a canal which was dug in 1833 to excavate peat in the area. Over time, the peat was turned into agricultural land by gradually covering it with sand, adding animal dung, and by application of fertilizer. The result was soil, which was good for agriculture because it had high levels of organic material, but had a highly unstable structure that made it susceptible to wind erosion. Today, Valthermond and its surrounding areas in Drenthe are essentially large stretches of flat agricultural land. Pesticide and plastic is used on these agricultural fields, so there's a lot of pesticide and microplastic residue attached to the soil. When this unstable soil is carried by wind over long distances across this flat landscape, microplastic and pesticide residues are transported along with it.
Within the SOILPROM project, we are focusing on understanding the transport and fate of microplastics and pesticides within the agricultural systems. This is particularly through wind erosion and atmospheric transport. So far there is very limited data sets on how these particles move basically in long term. Within our use case, we are conducting long-term field campaigns. And with these long-term data sets, we hope that we can validate and calibrate the models better.
A data model called microHH is used to develop scenarios related to wind erosion and atmospheric transport. The SOILPROM project is upgrading the model by enhancing its modeling of the soil-atmosphere interface and by calibrating it for microplastics. Upgrade of the model will involve use of existing databases, as well as primary data collected as part of the project. In Valthermond, data is being collected through various mechanisms. The BSNE catchers, or wind catchers, essentially sample dust particles blowing in the wind.
Yeah, what you see here are dust catchers. There are 5 dust catchers mounted on a mast because we wanted to get a vertical profile of dust and the dust distribution. And what you see is that these catchers are connected to a wind vane, which orientates the catcher in the direction of the wind. And this allows dust that's coming with the wind to enter a very small inlet and then to deposit at the bottom of the catcher. We collect dust from these catchers every 2 weeks. We bring them to the farm and we clean them and we collect the sediments that deposited into the catchers. And with the sediments that we collected, we bring them back to Wageningen to get analyzed later on.
Dust samplers are being used to capture very fine dust particles. This white thing is the filter, right?
Yeah.
The dust collected is being analyzed for pesticide and microplastic concentration. Wind erosion is also measured acoustically through devices called saltiphones.
Yeah, so these are saltiphones. You see they are moving in the wind, so the tail is moving it into the wind. So this tube is pointing towards the wind, so the wind goes from here to there. And then inside here there's a small microphone, and if a dust particle hits that microphone, it is recorded with the sound box in here, and then we can count the amount of particles hitting the microphone inside of this tube.
Along with the dust particles collected and the saltiphone readings, a range of weather data is collected through a weather station.
So this is a weather station. We of course measure the precipitation with this tipping bucket rain gauge. Then we have here in the background 4 cup anemometers, which we measure the wind speed at different heights. And then on top of the mast we also have a wind vane for the wind direction. The camera is looking at the field. It's pointed towards the catchers, but also to the field, looking at what is happening, what's the status, how much crop cover do we have, are there maybe machines driving across the field that might cause dust. And then we can also check the wind direction. This is the Sonic 3D anemometer. It can actually measure, it can create a 3-dimensional image of the wind profile of the field that it is aimed at. It's really important to have this information to make a good model of how much wind erosion you have at certain wind speeds at a certain field configuration.
This data, which will also feed the micro-HH model, will help correlate wind erosion levels to local weather processes.
Within SOILPROM, we combine field measurements of wind erosion, atmospheric particle concentrations, microplastic and pesticide analysis, and meteorological data. And each of these data sets captures a different piece of the transport process. So by combining these data sets and feeding it into the model, we can estimate how far these particles can move and in which direction. In general, transport through wind erosion is very new, especially when it comes to microplastics. We don't know that much about aerodynamic behavior of plastic particles. But for example, for pesticide, there has been some studies. We also conducted it at Wageningen University, and surely these particles are transported by wind erosion. But as I said, the long-term data set is actually missing, and that is very much needed to have an evidence for this transport.
In the context of SOILPROM, there are multiple case study sites, and we are looking at a range of emerging contaminants, and similar type of data are collected elsewhere. And the improved process understanding will be used to improve simulation models to predict fate and transport of those compounds. That will reveal the possibility to also run scenarios about what happens if you change policies or land management in order to minimize the risks of soil pollution. So there's concern in society, but also at governmental level, including the European Commission, about how pollutants are moving across our ecosystems and potentially affect ecosystem health, but also human health. And from that perspective, they want to reduce soil pollution as much as they can. And with the improved models which will be developed in SOILPROM, at the end we will be capable to run different types of scenario analysis to see which solutions fits best.